Hello dear students, so this is Nyamatulla Patel. So this is video number 3 on module 1. So in this module we are going to discuss metadata repository and data cube. In detail we will discuss what is metadata repository and data cube. So before going to the metadata repository and data cube in detail, let us understand some of the terms that we are using in a 3-tier data warehouse architecture. So when you are giving a data from operational databases and external sources to the bottom tier, that is data warehouse server, we perform certain operations on operational data as well as data from external sources. We perform operations such as extraction of data, cleaning of data, transformation of data, loading of data and refreshing of the data. So before data is given for analytical processing, data need to be extracted, data need to be cleaned, data need to be transformed, and then the data is loaded and we perform certain refresh operations, so that the data whatever you are giving to the OLAP server is properly analyzed and there is no missing data or the data which may contain noises. Okay, so we use the term extraction, transformation and loading of data. Data warehouse system use backend tools and utilities to populate and refresh the data as shown in the previous diagram. So here we have seen as this part, before data is given to the bottom tier of data warehouse server, we perform extraction, cleaning, transformation, load and refresh operations. Okay, so data warehouse systems use backend tools as well as some utilities in order to populate and refresh their data. These tools and utilities include the following functions. So first one is data extraction. So what we do in a data extraction? Data extraction, typically what it does, it gathers data from multiple sources. It gathers data from heterogeneous sources. It gathers data from multiple heterogeneous and external sources. So the data whatever we are giving it to the OLAP server is not only from only one point or not only from only one source. We will be gathering data from multiple sources and these multiple sources are heterogeneous, they are not homogeneous, they are heterogeneous data, and some data may come from the external sources and some of the data may come from the internal sources too. Next, coming to the data cleaning. What data cleaning does? Data cleaning which detects errors in the data and rectifies them when possible. So if a data contains an error, if the data is not complete or data is replicated or some part of the data is missing, at that point we use data cleaning which detects errors in the data and rectifies them whenever it is possible. Next, coming to the one more important function called as data transformation. So what data transformation does? It converts data from legacy or a host format to the warehouse format. As we are gathering data from multiple heterogeneous external sources, the data that is coming to the data warehouse is not as per the warehouse format. So we need to convert data from a host format to the warehouse format, so that it can be properly transformed, so that it can be properly analyzed and OLAP operations can be efficiently performed. Next, coming to the loading of the data. So, before we load data to the OLAP server, what we need to do? We need to sort the data. We need to sort the data according to which type of application it belongs, or which type of classification it belongs, or depends on the attribute. I need to sort the data, I need to summarize the data, then consolidate the data, then it computes the views, checks for the integrity, checks to see that none of the data is losing its integrity, none of the data is missing, and it builds indices and partitions. Okay, next, coming to the refresh, which propagates the updates from the data sources to the warehouse. Now, refresh, whenever there is a new data comes from the external sources, this refresh operation propagates the updates from the data warehouse to the warehouse. Besides cleaning, loading, refreshing of the metadata and metadata definition tools, data warehouse system usually provide a good set of data warehouse management tools. Data warehouse management tools are also available. So, data cleaning and data transformation are important steps in improving the data quality. Data cleaning and data transformation, these are the two important steps in improving the data quality and subsequently the data mining results. Because we are mostly interested in the aspects of data warehousing technology related to the data mining. Okay. So, these are what the important functions that are performed onto a data before that data is fed to the OLAP servers. Next, coming to the metadata repository. What is a metadata repository? Metadata are data about data. What it is? Metadata is a data about data. When used in a data warehouse, metadata are the data that define warehouse objects. Metadata defines what are the warehouse objects. As we have seen in the 3-tier architecture, metadata repository is one of the important component. Okay. So, this metadata repository is at the bottom tier of a data warehouse architecture. At the data warehouse architecture, if you see the diagram of a data warehouse architecture, so metadata repository is at the bottom tier. Metadata are created for the data names and definitions for the given warehouse. Okay, so additional metadata are created and captured for timestamping and extracted data. Additional metadata are created and captured for timestamping and extracted data. So, the sources of extracted data and the missing fields that have been added by the data cleaning or integration process. Okay, so a metadata repository should contain what a metadata repository should contain. A metadata repository should contain the following: a description of the structure of the data warehouse. So, a metadata repository contains what is information related to what is the structure of a data warehouse, which includes warehouse schema, views, dimension, hierarchies and derived data dimensions, as well as data mart locations and contents. Then operational metadata. What operational metadata does or what it includes? Operational metadata, which includes data lineage, history of the migrated data and the sequence of transformation applied to it. So, operational metadata includes the data lineage. What is data lineage? The history of the migrated data and the sequence of the transformation applied to it. Concurrency of the data, active, archived or purged data, concurrency of the data, and monitoring information, that is warehouse usage statistics and error reports and audit trials. This also is a part of metadata repository. Then metadata repository also contains the algorithms used for summarization, which include measure and definitions, dimension definition algorithms. Which type of algorithm a metadata repository contains? It contains algorithms, measure and dimension definition algorithms, data on granularity, partitions, subject areas, aggregation, summarization and predefined queries and reports. Okay, then continuing, again the metadata repository contains mapping from operational environment to the data warehouse environment. So, data that is coming from the external sources, I need to map that operational data to the data warehouse. The format conversion, which includes source databases and the content gateway descriptions. So, metadata repository also includes the source databases, the content and the gateway descriptions. Data extraction, how data is extracted, data partitions, cleaning, transformation rules and defaults. So, what is the type of gateway we are using, complete description of that, how data is being partitioned, complete description of that, how data is extracted, complete description of that, how data is cleaning and transformation is done, complete description is that. Data refresh and purging rules, how this is done, and security. To take care that a particular user, an authorized user only can access the data. So, here metadata repository is also responsible for user authorization and access control. Data, next metadata repository also contains data related to system performance, which includes indices and profiles that improve data access and retrieval performance. So, that metadata repository is also responsible for taking care that data is properly accessed, and whenever you want to retrieve the data, the retrieval performance is also good. In addition, it also includes rules for timing and scheduling of refresh. So, when a refresh has to be done, when a data has to be uploaded and when a replication cycle has to be run. Then business metadata, which include business terms and definitions, data ownership information and charging policies. These are all the part of a metadata repository. A data warehouse contains different level of summarization, of which metadata is one of them. Metadata play a very different role than other data warehouse data and are important for many reasons. Why metadata is an important part of a data warehouse? Because it plays a very different role than other data warehouse data. It is important. Why it is important? For example, metadata are used as a directory to help the decision support system analyst to locate the contents of the data warehouse, and as a guide to the data mapping. Metadata is what? It is guide to the data mapping when data are transferred from operational environment to the data warehouse environment. Metadata also serve as a guide to the algorithms used for summarization between the current detailed data and lightly summarized data, and between lightly summarized data and highly summarized data. Metadata should be stored and managed persistently, that is on the disk. It should be taken there that metadata is properly stored and managed persistently. Okay, next, coming out to the data warehouse modeling, data cube and OLAP. Data warehouse and OLAP tools are based on multidimensional data model. This model views data in the form of a data cube. Okay, so as you know, data warehouse and OLAP tools are using multidimensional data model. So this model views data in the form of a data cube. Okay, so data cube, a multidimensional data model. What is a data cube? What is a data cube? Before going into the multidimensional data model, let us understand the definition of what is a data cube. A data cube allows data to be modeled and viewed in multiple dimensions. It is defined by dimensions and facts. A data cube, what it does, it allows data to be modeled and viewed in multiple dimensions. It is defined by dimensions and facts. A data cube such as sales, consider a data cube contains a data related to the sales. So data cube will allows data to be modeled and viewed in multiple dimensions. So dimension table multiple dimensions. So dimension tables are created, such as a dimension table may contain an item, name of the item, brand and type of the item, or it may include the time. A dimension table may contain a complete information related to a particular item, or it may contain a particular information related to the time, consider on which day, which week of the month, which quarter and which year. Okay, so here fact table contains measures such as dollars sold and keys to each of the related dimensions. In data warehouse literature, a ND base cube is called as a base cuboid. The topmost 0D cuboid, which holds the highest level of summarization, is called as the apex cuboid. The lattice of cuboid forms a data cube. Okay, then let us view a 2D view of sales data for all electronics according to the time and item. So here we have a table, and this table is giving a information related to the sales of all electronic items according to the time and item. So here we are taking time and item into consideration. So here the location is Vancouver location, is one city where I am viewing all the sales data for all electronics item according to the time and item. So here item type, what is the type of the item? So here a complete year is divided into 4 quarters, Q1, Q2, Q3 and Q4. Okay, and let us say the branch location, it is located into the, so here we are taking the location, the city of Vancouver. So here the measures displayed, it is in terms of dollars sold in thousands. So this is a 2D view of sales data. So here the time we have taken is 4 quarters of an year, 3 months, quarter 1 includes 3 months, quarter 2 includes 3 months, quarter 3 includes 3 months and quarter 4 includes 3 months. And what are the different type of electronic items over here? One is home entertainment item, another is computer, another is phone, another is security related items. During quarter 1, if you see, during quarter 1 around 605 home entertainment items, that is in terms of dollars sold, $605,000, computers $825,000, $14,000 and $400,000 measures. Or next, if you take the quarter 2, 680, 952, 31 and 512. So, this statistics, what it is giving? It is giving you the total number of electronic items sold according to the time and item in a city called as Vancouver during an entire year, and we have divided the data according to the item type, either it may be a home entertainment, or it may be a computer, or it may be a phone, or it may be a security related item in 4 different quarters. Let us go for the 3D view. So, now 3D view of sales data for all electronics according to the time, item and location. So, now here we are taking into consideration what we are consideration, we are including one more item, one more important thing, that is called as location. In the previous table we have taken only time and item, and now here we are including a location. Now, this is a 3D view. Now, there are 3 types of data over here, 4 types of data over here. We have taken 4 different locations. One is Chicago, another is New York, another is Toronto and Vancouver. And again the item, the same type of the item, home entertainment, computer sales, phones and security in Chicago, the items sold in New York, and items sold in Toronto, and items sold in Vancouver. This is again the same data, whatever we have represented here, it is only for one city. When I combine such type of data for multiple number of locations, then it becomes a 3D view of sales data. So, that is what a 3D view of sales data for all electronics according to the time, item and location. Next, coming to the lattice of the cuboid. So, here in figure 3 shows the lattice of cuboids forming a data cube for dimensions time, item, location and supplier. So, now here one more thing is added. So, in first thing we have taken into consideration only time and item, that is 2D view. In 3D view we have taken time, item and location, and in the lattice of cuboid we have taken 4 things. One is time, another is time and item, then time, item and location, then time, item, location and supplier. So, figure 3 shows the lattice of the cuboids making up a 4D data cube for time, item, location and supplier, and each cuboid represents a different degree of summarization. Okay. So, the cuboid that holds the lowest level of summarization is called as the base cuboid. Okay. So, that is this one, the 4D. The cuboid that holds the lowest level of summarization is called as the base cuboid. For example, the 4D data cube that is shown in the figure here, the cuboid that contains item, time, item, location, summarization for all the suppliers, that is 4D, that is base cuboid. Whereas 0D cuboid, 0D cuboid which holds the highest level of summarization, it is called as the apex cuboid. So, here all the things are considered taken into consideration. So, this is apex cuboid, that is 0 level, and 4D cuboid is a base cuboid. Then you have 1D cuboid, 2D cuboid and 3D cuboid. So, 0D cuboid or the apex cuboid hold the highest level of summarization, and it is called as the apex cuboid. In this example, this is the total sales or dollars sold summarized over all the 4 dimensions. So, here what the apex cuboid contains? Apex cuboid contains all the summarization summarization, complete summarization with respect to the total sales or the total dollars sold, summarized over all the 4 dimensions with respect to the item, time, location and supplier. Okay, the apex cuboid is typically denoted by all. So, here the apex cuboid I am representing it by the all. So, now you can see over here 0 cuboid or the apex cuboid contains all the 4 dimensions. Then 1D cuboid. So, this cuboid contains all the information only related to the time during which year, which quarter, which month, which week and which day a particular sale has been occurred. 1D cuboid contains. Another 1D cuboid is an item that only deals with which type of item is sold. Then here in what location a particular item is sold, and V is the supplier and which supplier item is sold most. Then 2D combines 2 items, 2 attributes. So, here it is taking only one thing, that is item or the time or the location or the supplier, and the 2D cuboid contains time or item, time, item and location, item or supplier, item supplier, item location, location supplier. Now, 3D cube will contain 3 parameters, either it may be time, item, location, time, item, supplier, time, location, supplier, time, location, item, location and supplier, whereas the base cuboid contains time, item, location and supplier. So, the complete information is present over here. So, whatever level of data you want, you can extract it from the lattice of the cuboid. Given a set of dimensions, we can generate. So, here either you can get all the data, or if you want only data related to the time, item, location and supply, you can extract from 1D cuboid. If you want the data from item, time and item, 2 parameters if you want to take, either time and item, item location or item supplier, time supplier, location supplier, you can access from the 2D cuboids. So, if you are related to 3 things, time, item, location, time, item, supplier, time, location, supplier or item, location, supplier, you can access this from 3D cuboid. And if you want all the data related to the time, item, location and supplier, you can access from 4D cuboid. So, now each level of extraction is present over here. What type of data you want? So, the lattice of cuboid will give you an efficient data access. Which type of data you want, you can extract it from either the 0D level of cuboid, 1D level of cuboid, 2D level of cuboid or 3D level of cuboid, or from the 4D level of cuboid, that is the base cuboid, will get all the complete data. So, each cuboid here represents a different degree of summarization. So, given a set of dimensions, we can generate a cuboid for each of the possible sets of the given dimensions. The result would form a lattice of the cuboid, that what we have discussed in the previous slide. So, each showing a data at a different level of summarization or by group. The lattice of cuboid is then referred to as a data cube. Figure 3 shows a lattice of the cuboid forming. So, that is whatever we discussed, shows a lattice of cuboid forming a data cube for dimensions time, item, location and supplier. The cuboid that hold the lowest level of summarization is the base cuboid, that already we have discussed. So, this is in this video what we have discussed. So, in this video we have discussed what is a data extraction, data transformation and loading, what is a metadata repository and how important is metadata repository is required, then what are the important functions a metadata repository does and what information a metadata repository, that all things we have discussed. Then we have discussed data warehouse modeling, a data cube and OLAP. We discussed a 2-dimensional view of the data, 3-dimensional view of the data and 4-dimensional view of the data in the form of a lattice of the cuboid. That is, this much is sufficient for this video. In the next video lecture, we will go for the star, snowflakes and fact constellation, that is schemas for multidimensional data models. Okay. So, thank you one and all.